Hello everyone, this is Navya. Welcome to my YouTube channel, Know Chemistry, Enjoy Via Learning. Today we are going to learn periodic table and its classifications. Periodic table. It is a bunch of elements which arranges all of non-chemical elements in an informative order. All these elements show some physical properties and chemical properties. There is a huge history behind this periodic table. Firstly, a German chemist, Daubernier, arranged these elements in an order and he called it triads. And the law of triads he stated is, the middle element of each of the triad had an atomic weight about halfway between the atomic weight of other two. When you observe this table, lithium has an atomic weight of 7 and sodium has an atomic weight of 23 and potassium of 39. So 7 plus 39 is 46 and when you halfway it is 23. So I get sodium's weight. So by observing this, he gave this order that lithium, sodium, potassium, calcium, strontium, barium, chlorine, bromine and iodine. But it is applicable only to some of the elements but not to every element. So his work is unnoticed. Nextly, a chemist, John Alexander Newland, stated law of octaves that every eighth element had the property similar to that of first element. Here you can see that there are 7 elements and the sodium next is 8th element which has similar properties to that of lithium and potassium which has similar properties to that of sodium and lithium. So these are placed together, lithium, sodium, potassium, beryllium, magnesium and calcium. So this relationship seemed exactly like octaves in music. So he named it as law of octaves. But after calcium, 3D transition series starts and the properties differ. So it is valid up to only calcium. So his work is also been unnoticed. Next, coming to Mendeleev, noticing physical and chemical properties like melting point, boiling point and atomic numbers, Mendeleev proposed periodic law that constructs a periodic table and he stated that the properties of elements are periodic functions of their atomic weights. Here you can see 2 new words, that Eka silicon and Eka aluminium. So what are these? At the time of Mendeleev, germanium and gallium elements were not found. So he kept blanks under silicon and aluminium blocks and named them as Eka silicon and Eka aluminium. And his predictions were right. After germanium and gallium were found, they are kept into this Eka silicon and Eka aluminium blocks. So Eka silicon is nothing but germanium and Eka aluminium is nothing but gallium. But Mendeleev completely ignored order of atomic weight. He placed the elements with similar properties together. For example, atomic weight of iodine is greater than that of tellurium, but iodine is placed in fluorine family because of its properties. Now coming to Henry Moseley, he modified the Mendeleev's periodic law and stated a modern periodic law. It states that the physical and chemical properties of elements are periodic properties of their atomic numbers. Now we'll jump into long form of periodic table. This is the long form of periodic table. These vertical columns are called groups and the horizontal rows are called periods. So there are 18 groups and 7 periods in total. S block is present in left side of the periodic table, P block on the right side of periodic table, D block in between S and P, and F block at the bottom of the periodic table. So S block contains two groups. One is alkali metals and second one is alkaline earth metals. Coming to P block, there are families. It's boron family, carbon family, nitrogen family which is also called nicogens, oxygen family which is also called chalcogens, and fluorine family which is also called halogens. And this 18 group are called noble gases or inert gases or rare gases. They rarely react with other elements, so they don't react that easily. Now coming to this D block elements, it comprises of groups from 3 to 12 and these are called transition elements except zinc, cadmium and mercury. So why are these called transition elements? Because they show various color properties, oxidation states and they form colored ions except zinc, cadmium and mercury. Because these are fully filled orbitals and that doesn't show colored properties. So every transition element is a D block element but every D block element is not a transition element. Coming to F block, this contains 2 rows which are lanthanides and actinides. Here you can see, and they are all metals. So S block and P block are collectively known as representative elements and D block is known as transition elements and F block are known as inner transition elements. So for elements whose atomic number is greater than 100, there is an IUPAC nomenclature for these elements. So you can see here the digit, name and abbreviation are present here. So for example, the IUPAC name for number 109. So for 1 it's UN, for 0 and it's nil, and for 9 it's ENN, and the name is anilinium. So the abbreviation is UNE, and it's that simple. So as we discussed earlier, S block elements are present on left side of periodic table. There are two groups in it, alkali metals and alkaline earth metals. Its outermost electronic configuration tends from NS1 to 2. It means for alkali metals it is NS1, and for alkaline earth metals it is NS2, the outermost electronic configuration. So these groups, they lose outermost electrons and become electropositive elements. They are reactive metals. Their reactivity increases from on going up to down, and they are with low ionization enthalpy. So what is ionization enthalpy here? It is the amount of energy required to remove an electron from isolated gaseous atom. So for example, there is a sodium atom here. So we apply energy on sodium atom. So then it emits an electron and becomes a unipositive element. Because of high reactivity of these groups, they are never found in pure state in nature. Coming to P block, it is present on right side of periodic table, and S block and P block are collectively known as representatives. It is comprised from group 13 to 18. There are families in this group, and they gain electrons and become electronegative. Reactivity of noble gas is very low, as I discussed earlier. So what is electron gain enthalpy here? It is the amount of energy released when an electron is added to an atom. So for this sodium atom, we added an electron and then it emits energy. And next, coming to D block, it is present in between S block and P block, comprised of groups 3 to 12. They're all metals, especially Zn, zinc, cadmium and mercury are D block but not transition elements. Coming to F block, it is present at the bottom of periodic table, consists of 2 rows, and they are all metals. Now comparing the nature of metals and non-metals, metals, they are solid at room temperature. They usually have high melting and boiling points. They are good conductors of heat and electricity. They are ductile in nature and they are malleable in nature. So what is ductile? You can make them into thin wires, and malleable, you can make them into thin sheets. And coming to non-metals, they are solid and gas at room temperatures, and they usually have low melting and boiling points. They are bad conductors of heat and electricity. They are not ductile and malleable in nature. So the elements showing both the properties are metalloids. As you see in the periodic table, this left side, these are metals and these are non-metals. As you go down the group, metallic nature increases. As you go from left to right, the non-metallic nature increases. Next, coming to the most important topic in this chapter, trends. How these trends vary in groups and periods. So first, coming to atomic radius. What is atomic radius? Consider that if it is an atom, and this is nucleus of atom. Okay. And the distance between the nucleus and the outermost path is called atomic radius. How this varies? It increases in groups and decreases in periods. If you see here, lithium to francium. From lithium to francium, atomic radius increases. So francium has higher atomic radius, more atomic radius than lithium. And in periods, it decreases. It decreases in periods. And you can see here ionization enthalpy, electron affinity, electron negativity. These decreases in groups and increases in periods. Coming to electropositivity and metallic nature, they go on with atomic radius. So here if you observe the atomic radius, electropositivity and metallic nature, they show the same trends in groups and periods. They increase in groups and decrease in periods. And coming to next, ionization enthalpy, electron affinity, electron negativity and non-metallic nature. These decrease in groups and increase in periods. If you see here. So next, isoelectronic species. What are these? The species with same number of electrons but radius is different. Those are called isoelectronic species. See, if it's sodium, sodium atomic number is 11. Sodium atomic number is 11. It loses one electron and now it has electrons is 10. And you know that neon has 10 electrons in it. And fluorine, normally it has in electrons 9 electrons, and now it gained 1 electron. See, negative charge is there, right? Now it gained 1 electron, so it's 10 electrons it have. So these three have same number of electrons, but the radius is different. These are called isoelectronic species. So this is all for this video. If you want me to make a detailed video on periodic table about groups, periods, electronic configurations, just comment down below. In next video, I'm going to come with some easy and interesting problems on this topic. So stay tuned. I hope you like this video. Share it with your friends and don't forget to subscribe and hit the bell icon. You can also follow me on Instagram. The link is given below in the description. Thank you.